So, good afternoon. So, in the morning period, we were just doing an important topic on moderate speed offset or moderate speed offset frontal crash worthiness evaluation. So this test, we could see that entire thing we had gone through right from test condition and test vehicle and dummies preparation till execution of test and looking at different measurements and their responses through various sensors. So in the similar fashion, today also we are going to do in this period, what is that crashworthiness evaluation of a vehicle in a side impact. So before that, I would like to play two videos so that we will comprehend what we were doing in the previous lecture, that is offset impact. So comprehensive way of we are visually seeing those tests, what we have dealt with in the morning would be more retained in your mind. I thought so. I would like to play two videos and then we'll go ahead with today's lecture and end with the possibly one or two videos. And that is what is my plan for this one period lecture, right? So for that purpose, let me share my screen. So I hope you're able to see this media player, right? So let us just look at how this crash test preparation is first carried out. So for that, we have one good video. Let us just listen to that video and then go ahead with our lecture. Are you able to hear the audio as well?
No, sir.
No, 1 minute. Then I have to.
No, sir.
Yeah, just a minute. Let me share once again. Yesterday it was done, right? Just a minute. So let me share now. So I hope you'll be able to hear now with the audio as well.
My name is Andrew Breathwaite, and I'm.
So are you able to hear the audio?
Yes.
Yeah.
I'm a research engineer and test coordinator at the Insurance Institute for Highway Safety. The role of the test coordinator begins when the vehicle first arrives at the VRC. After checking the vehicle in, the test coordinator oversees the entire test preparation process. One of the first test preparation steps is to correctly position the vehicle seats. We follow a standardized protocol and use a device that represents a human occupant to determine exactly where the dummy should sit. Next, we take measurements of the vehicle structure so that we can measure intrusion after the crash. After that, the vehicle is turned over to the vehicle prep team, who get the rest of the car ready for the test.
Every vehicle that comes into the Institute is assigned a crash test number and a book. This book is our little Bible. It's our checkoff sheets. For everything we do to this vehicle, we need to initial it and date it. This book follows the vehicle all the way through the process, right till post-crash.
I'm just going to do a very quick inspection underneath the vehicle just to make sure that there's no previous damage. I'm draining all the fluids out of the vehicle. That way we don't make a mess right after the crash.
Now that we've drained the fuel from this vehicle, we're going to go ahead and replace that with a solvent that we've dyed purple. It weighs the same as gasoline, but it has a higher flash point.
Just waiting for the gas to come out. There we go. Purple. We're good. Now we have all the gas out. Purple is in the lines, so if there's any leaks, we'll be able to detect them.
We're putting the rack in the vehicle right now. We're getting ready to install all this instrumentation here. It has to be bolted to the heaviest part of the vehicle through the floor so that it doesn't pull loose, doesn't bend. Right now we're installing all the boxes and power supplies to run all the equipment that we're going to be attaching to the vehicle.
The majority of our onboard equipment is mounted in the trunk of the vehicle. This includes power for our onboard camera systems, power for data acquisition, and also our onboard braking unit.
So I've cut the brake lines, and I'm going to be putting some fittings on these lines and a hose which will run from these lines to the back. The red box I'm going to attach these to actually fires nitrogen into the rear brakes, and that's what's going to stop the car if we should need it.
Here are the onboard digital cameras that we're going to be mounting on the door. We need to remove this door panel so we can tie into some stiff structure. Now the front cameras and lights are installed. We're going to move into the rear of the vehicle where we're going to install the rear cameras. So I'm going to measure this and make sure that it's in the exact same spot so the shot looks the same from vehicle to vehicle.
We just bolted the chains on. I welded some hooks onto the subframe on either side. This chain is actually what's going to hook to a skate in the floor, and that's going to pull the car down the runway.
Right now, what you're seeing taking place is striping the center of the vehicle. We'll be using these marks in order to align the vehicle on the crash machine before it's tied down. The reason we put targets on the vehicle here is so that we can actually measure the reaction of the dummy and the vehicle itself. We have marks on the side, on the roof. What we can see then is how much the dummy moves from one point to another, how much the steering wheel may move. We can use this for various measurements when we analyze what happens after the crash. We're getting ready now to do the final step in vehicle prep, and that's the weighing of the vehicle. We have all our instrumentation in place, and we've added weight to simulate the dummy being in position. This takes just a few minutes, but it's one of the most important things we do. This weight is put into the crash machine and is part of the equation for making sure our speed is right on the money. After the vehicle is fully prepped, it's moved to the crash hall.
The purpose of wheeling the car out into the crash hall before the test is twofold. One, so that we can line the vehicle up at point of impact, and also so that we can frame and focus both our onboard and offboard slow motion cameras. The dummy is also placed in the vehicle in the crash hall before it's pushed down the runway, where it will sit overnight in a temperature-controlled shed.
418.
In the morning, we proceed with our final preparation before testing, which includes tying the vehicle down to the crash machine, seating the dummy, and applying grease paint so we can determine contact points, and making any last-minute adjustments to our onboard instrumentation.
Main battery voltage 12.8.
After everything has been completed and checked, we exit the shed and the test is initiated from the control tower in the crash hall.
Charging is now complete. Test will commence in 4 seconds. 3, 2, 1, we're underway.
So you are able to look at.
My name is Andrew Breathwaite, and I'm a research engineer and test coordinator at the Insurance Institute.
Yeah. So this video is very interesting video that is completely brought in what we were doing in the morning period. So it shows right from receipt of the test vehicle and required inspection that there are no damages. Anything is present in that, and then complete removal of fuel and replacing that by a solvent, and continuing with that, the preparation of instruments and power packs at the rear hood of the vehicle, and so on. So what all that in the morning lecture that we have seen, the preparation of your test vehicle for your crash test could be nicely witnessed as if an virtual industrial visit to IIHS. So I think you would appreciate and understand those things easily as you go through this video again and again and make your own observation and sequence of steps involved in conduct of in preparation of the test vehicle for the conduct of crash test. So this type of preparation is common for any type of crash test configuration that we are going to discuss. Right. So let me play one more video and continue with the class. So let us look at what test that morning we have seen and that test how it's been carried out.
I'm Joe Nolan. I'm the Vice President of Research for the Insurance Institute for Highway Safety. Frontal crashes are the most common type of crash that results in serious injury or death. Most of these crashes don't happen head-on where both vehicles are lined up. Rather, there's some amount of offset between the vehicles. The Institute's 2 frontal tests help you evaluate how well your vehicle might protect you in these types of crashes. In our moderate overlap frontal crash, a vehicle strikes this barrier at 40 miles an hour with 40% of the vehicle's front end width lining up with the barrier. This section of the barrier is made out of aluminum honeycomb that crushes like a real car would in a crash, and it's mounted to a larger barrier that's 320,000 pounds of steel and reinforced concrete. The second type of crash we call a small overlap crash. We accelerate a car down a track into this barrier at 40 miles an hour with only 25% of the front end of the car lined up with the edge of the barrier. This barrier is rigid. It's got a radius of 150 millimeters. That's about 6 inches. And that represents what happens when you hit another car in that small overlap, or you hit a tree or a pole or a post. We evaluate frontal crashes using 3 criteria. The first is how well the safety cage held up and protected the occupant from intrusion and injuries related to the forces of the crash. The second is measures from the dummy itself on the risk of injury in the crash. And then the third criteria is how will the restraint system, seatbelts and airbags, work to protect the occupant and keep the occupant away from any injurious impacts.
My name is Chris Sherwood, Senior Research Engineer at the Insurance Institute for Highway Safety. When we assess vehicle structural performance in frontal crash tests, we look at the amount of deformation or intrusion at a series of locations inside the occupant compartment. It's important for vehicles to minimize this deformation because as those structures come back toward the occupant, it's much more likely to cause injury. In this vehicle, the structure had poor performance. The wheel was pushed rearward into the lower part of the occupant compartment, causing a lot of intrusion into the footwell. The pillar, the instrument panel, and the steering wheel were also pushed rearward and inboard, and this increases injury risk to the occupant.
Hi, my name is Becky Miller. I'm the crash test coordinator and research engineer. What we have here is a display dummy that's cut away so you can see all of the different sensors and components in the dummy. We have sensors in the head and the neck, the chest, the upper leg, the lower leg, and the foot, which all measure risk of injury. Today, in moderate overlap crashes, dummy injury measures tend to be low for all body regions. This is because vehicles are designed for this crash mode and restraint systems properly protect occupants from injury. In small overlap crashes, some vehicles do a good job of protecting the occupant inside. In other vehicles, we may see high risk of injury. This is because many manufacturers have not designed for this crash mode yet.
Okay, so these 2 videos I have purposely played so that what in the last period, a morning lecture that you have gone through could be best understood and realized. And if you go back again to the video lecture I have which is uploaded in our channel, last lecture, you go through that again, you would follow what I was trying to explain you one by one. So we will have always this course with notes and then no necessary videos. So we have got a good aid of learning this content of the course. So with that, let me continue with today's class and another important test that is side impact crash test. So let me share for that my slide and second. So you have anything that you want to discuss on those watched video? Do you have to discuss anything on those watched video? Do you have any doubts, or are you able to correlate with what we have done in the morning lecture, right? So you could see that the coordinate measuring machine is what is used to have spatial coordinates of an important key points, whereas before pre-crash and post-crash events happened, you would see how much the pillars intrusions or the in front panel intrusion that come into the cabin can be easily measured. So the CMM, coordinate measuring mission, is what is that? You could see that was used in the video to take all the space points, coordinates before crash test and after the crash test. So with that, let me just share now for today's topic of side crash test. So let me share this slide. Hope you are able to see the slide. Like in the morning, we have seen for offset crash test. In the morning, we have seen moderate overlap, frontal crashworthiness evaluation. So moderate overlap refer to 40% overlap of the test vehicle with the deformable frontal barrier is what that you have witnessed. Right. So why such test to be carried out is because when two colliding vehicle head on with some small moderate offset, what would happen is what to test. So this test was conducted, right? So let us look at now in the similar way, how did you learn to the side impact crashworthiness evaluation. So again, this technical resource, the information that I present or from the technical notes that is published in Insurance Institute for Highway Safety, IIHS. So let's go with the lecture. So if you look at here, again, this test condition, impact configuration, it consists of two vehicles basically. One is this test vehicle, another one is this movable, deformable barrier vehicle, right? So you see this vehicle weight is 1500 kg, which is movable deformable barrier, has impact velocity 50 kilometers per hour and strikes the test vehicle on the driver side at 90-degree angle. So the driver side is here in US vehicle. So this is that configuration of the impact scenario. The longitudinal impact point of barrier on the side of the test vehicle is dependent on the wheelbase. So the test vehicle wheelbase is going to be important, how this barrier contact is going to have, right? The impact reference distance. So if you look at here, this is that what is impact reference distance. So that is measured that the center line of the barrier vehicle from the front axle of the test vehicle. So this distance is what is called impact reference distance. And this is such that the flat surface of this barrier, which is IIHS deformable barrier. So this barrier contact will be at the driver head. So the driver head portion will be coming on this flat surface. That is how this orientation is decided. That is how this impact reference distance is being chosen. So this MDB, this moving deformable barrier alignment calculation was configured to maximize loading to the occupant compartment and allow alignment of the driver dummy head with the flat portion of the barrier face. That's what I was just telling you. So this IRD calculation depends on wheelbase that you have seen. So if the wheelbase of the test vehicle is less than 250 centimeter, then the IRD supposed to be of this value 144.8 centimeter from measure from front axle axis. And if it is between 250 centimeter to 290 centimeter, then the calculation is the wheelbase divided by 2 plus 19.8 centimeter. So if it is greater than 290 centimeter, then this distance is obtained by 164.8 centimeter. So this is important IRD calculation, and that is going to decide the variant of side impact barrier test. Depends upon the vehicle wheelbase. So this MDB is accelerated by the propulsion system. So morning that we have seen the similar way in the video we have witnessed, the front is connected to the chain and the rear there is a rope, and that is being propelled by the pulley system. You could have witnessed in the video. So that would be underneath this complete test track. So it has been propelled towards the barrier. So here MDB will be propelled towards the test vehicle until it reaches the speed 50 kilometers per hour, and then it is released from the propulsion system 25 centimeter before the front of the impact with the test vehicle, which is similar to that morning test we have gone through. So impact point tolerance is plus or minus 2.5 centimeter of the target in the horizontal and vertical axis. The impact speed tolerance is plus or minus 1 kilometers to 50 kilometers per hour. So the MDB braking system, which applies the test kart service brakes on 4 wheels. So during the collision, the brakes are engaged, is activated by 0.5 seconds after it is released from the propulsion system. So when it is released from the propulsion system, just before 25 centimeter before that, the brakes are engaged and then it is released. That is 0.5 second after the release. The brakes are activated. Right, the brakes on the test vehicle are not activated during the crash test. The brakes on the test vehicle are not active because here the vehicle brakes are not put. It is as it is the parked vehicle, and but brakes are not activated. The brakes are not activated, right? So it's a free vehicle in front of this barrier. And then let's understand what is this configuration, the properties of this MDB from IIHS. So the MDB consists of an IIHS deformable aluminum barrier. So there are many versions. This one and the figure is what is version 4, which is similar to that of the crash cart. This is called crash cart, similar to that one used in Federal Motor Vehicle Safety Standard, given by 214 side impact test. Morning test, whatever we have seen, is 208 as per 208. FMVS is 208, and this side impact test, the regulations are 214. But has got several modifications. So this test card is from IIHS. So similarly, there is a test card of FMVSS 214. But there are some modification that are there that are explained in this paragraph. You may please go through. So what is important that there is the roll, pitch, and yaw angular the moment of inertia of this cart are given by these values. And these are all fixed. These are exact the property of this MDB. So the deformable element has a width. So you see here the IIHS deformable barrier. So the dimension of this deformable barrier with the cross section is what is given in this figure 3. So you could see the overall width is 1676 mm, the height of 759 mm, and the ground clearance of 379 mm when mounted on the test cart. So this barrier can be mounted on the test cart. So you have this base plate and which is rigid, and then it's mounted, and then this vehicle would be ready for execution of the test. So what is the difference from the morning test and this test? And the morning offset test, we have witnessed that the test vehicle is what is propelled towards the rigid with the barrier, frontal barrier, where the frontal barrier has got front portion again with the deformable barrier. So there are honeycomb structure. Similarly, you also have now in the side impact test, the test vehicle is just freely kept as a target, and this MDB is what is propelled through the propulsion system to hit the vehicle at right angle. And here also it has got some honeycomb structure, and the details are given in this picture. And vehicle preparation, test vehicle preparation, as we have seen in the video, it will be vehicle check for prior damage if anything is present, or any repair or missing parts, any fluid leakage is there, all would be first witnessed and corrected. All engine and transmission fluid are drained, which you have also seen in this video. So the gasoline is removed from the fuel tank and fuel lines and replaced by this TODOT solvent to 90 to 95% of usable capacity. The engine is started for a short period to ensure that this solvent would get filled with the fuel lines. And the electrolytes is drained from the battery and the air conditioning system. So this is all whatever that in the morning that we have seen. The same even for the site test, the test vehicle preparation. And then if we continue with that, you see that an aluminum instrumentation rack which supports the test equipment is installed. So we could see that on the hood they are installing in the cargo area of the vehicle. The carpeting in the area is removed to allow access to the floor. If necessary, the spare tires, auxiliary jack, tool compartment, and third row seats may be removed in case it is a long vehicle. The following test equipment is installed on the instrumentation rack located on the cargo area. The following test equipments is installed, it's repeated, sorry. So you can see here, there are two, compared to the morning, you have there some additional instrument, but in this side impact test, 12-volt battery monitoring system and high-speed camera, onboard lighting, power supply. So similar to morning what we discussed, these are the two items which are installed in the cargo area. Two camera mount platforms are installed on the non-struck side of the vehicle at location adjacent to the front and rear passenger window sills. So that's also important. So here you would see the camera positioning would be additionally added, which were there for frontal impact. You will have onboard cameras also for side impact test to witness. So the front and rear platform weighs 20 and 12 kg respectively. 3 digital onboard high-speed cameras along with the camera router are mounted on the platforms to observe dummy kinematics throughout the crash. Additionally, 4 LED light fixtures are mounted inside the vehicle. The total weight of the 3 digital cameras, mounting hardwares and camera routers, cables and lights all add up to 17 kg. A plastic block containing an array of high intensity LEDs is attached to the roof of the vehicle with the sheet metal screws. Additional LEDs are placed inside the vehicle in view of onboard high-speed cameras. And the pressure sensitive tape switch is applied on the driver's side of the vehicle such that it makes the first contact with the barrier during the crash. The pressure applied onto the tape complete. So this acts as a switch and to start the zero time and so on, what we have discussed in the morning. So similar procedure here as well. Then the test vehicle instrumentation, if you look at this figure, is something different from what we have seen in the morning. So in morning, there are some 14 locations that you could see, and there are 4 important 64 mm strips were there, centimeter strips were there. So here now you see this for the side impact, you have these are the different marking on your surface, exterior surface of the vehicle. So you see this impact reference distance that you understood. So you will have your barrier would have here the contact. So this is the flat surface contact going to be. What is this? This is what is going to be the center line of your, if I extend this. So this is what is the center line of your MDB. So MDB striker target, for example, is given here. So what is that striker target? Is this median line. So here, so this this is that what is the MBD striker target. And you see mid-door horizontal contour measure. So this mid-door horizontal contour measure, for that purpose, this tape is pasted. So you would see at that horizontal datum, the mirror image on crash side and non-crash side, crash side in post-crash scenario, in order to understand what would be the profile change or contour change and mid-door horizontal contour of this. So that would give the that would quantify what would be the intrusion that has taken place. So the vehicle center of gravity all are measured with respect to the distribution of load and so on. As you remove some and then add instrumentation and all loading, so this point would be calculated. So here this spot is for to refer what is CG location. So this is what is called this MBD striker target location. MBD striker target location. continuing with this, you can see addition to that, there is also anti-roll device that is mounted. So if you are doing a side impact test other than sedan class vehicle like SUVs or any van, then there are chances that after the side impact, there can be a roll over of this test vehicle. So in order to prevent that, you have this anti-roll device recommended by IIHS, right? So anti-roll device is made primarily of this Comoli structural tubing, and which weighs 42.5 kg. So this is maybe the great number, right? And it attaches the vehicle where the where the roof rail intersect the B pillar. That is this roof rail intersect the B pillar. So this is B pillar, roof rail intersect this point. So you have here is that first contact, and 2 points on the pinch wells under the door sills. So this is the door sills bottom frame. So these two sides. So this is how it is mounted. So the device is designed to allow a vehicle to rotate up to 5 degrees before further rotation is countered by spring of see, this is appearing like one bar, but this spring is this bar contains the tube contains a spring, and that would have 14.8 kilonewton per meter stiffness spring, and in the upper support member, which will allow an additional 5 degree of rotation before bottoming out. Before bottoming out means it can it won't make the rollover. It will go and then come and sit back, right? And if you look at driver seat and driver control placement, so again, this is the dummy preparation. You can go through this as I will be uploading this notes. And then you see rear passenger seat placement. So that one, which is the driver seat and driver control placement, is similar to whatever in the morning test that you have seen. But since side impact test, you put a rear passenger seat placement. So you would have that to be focused on side window and door locks, and transmission and ignition, and vehicle ride height. So what is vehicle ride height? If the vehicle has an adjustable suspension or it is equipped with an automatic leveling, those systems will be deactivated during the test. The ride height will be set to default vehicle parked condition, right? So what are this ride height adjustment is an active suspension system present in your vehicle. So when you drive your vehicle, you want to have your 3 important objectives of isolation, rattle space, or road holding. So you have their semi-active suspension system that's better suited. But that would work only during the drive of your vehicle. But when it is stationed, it won't. So the test condition should have the deactivation of any active suspension system is there, that should be deactivated. And then crash dummy preparation and setup, that whatever you have seen in the morning, similarly 50th percentile male hybrid 3 dummy with the instrumented lower leg is positioned in a driver's seat. A dummy is equipped with the feet and feet and ankles. The feet include 2 accelerometers, and ankles prevent metal to metal contact that result from bottoming of ankle bumper. Dummy's knees are equipped with ball bearing sliders. So whatever in the morning that we have seen, that same dummies are used. So here, importantly, see the dummy's head, knees, and shins are colored with a grease paint to facilitate post-crash identification of impact with the vehicle interior and or the striking barrier face. So you have the side impact, so the striking barrier face will come and hit. Otherwise, whatever this dummy preparation is same. The conditioning of dummy is very important. That morning you asked. That is necessary that it would be for almost 16 hours prior to the test would be conditioned with this particular 20 to 22.2 degrees centigrades with the humidity of 10 to 70%. So this also you could have seen that uttered in the video what you have watched. So the photography is very important because that is what is completely capturing the event, and that is what is quite useful for further analysis to do the complete estimation or evaluation of crashworthiness of the vehicle. So you have to have still photography for documentation, as we discussed in the morning session. And of course, you have an additional views because of the side impacts here. And high-speed motion camera photography is again very important, but the placement of high-speed motion photography is what we have to see now for this side impact test. And let us understand that from the following two tables and the figure 6A and 6B. So these two tables, like you have seen 6 locations for the offset frontal barrier test, you have additionally, you have 4 more cameras, GHIJ. So that is centered on MDB. So it will be onboard cameras. So these are onboard high-speed digital cameras. So front passenger window sill and front passenger window sill, there are 2 cameras there, and the rear passenger window sill. So the camera focal length are given. So in the video you could see that before the test to carry out, the vehicle has been brought to the rigid barrier, and they are seeing that offset exactly referring to that 40%, and then they put the tape. You could see that the cameras for the taking all are adjusted, the focal lengths are fixed, all those things that we were seeing in the video. So you see here for the side impact configuration, the additional HIJ, and there is another G location that is centered on MDB. So that would be, that's not appearing here explicitly here. See, it is centered at this. So this is the location, that another camera. So the 6 locations here is again is changed also. So when we had in the morning session, you had here the barrier and the vehicle approach here, and you had the locations like this. For the side test, these are the locations. So what is important from this slide is what are the different locations the cameras are fixed. What is the spatial position they are fixed from the coordinate. What are the focal length that each cameras are going to have. So these are all something that you would get out of this table and this picture, and which can be readily referred if you have this picture in your hand, right? And then coming to the measurement and observation part, the test weight is measured for CG calculation, and then impact speed. So this is all something that's similar to what we were discussing in the morning. But here an impact point is something new, because it's a side impact, and this exterior surface markings are different from the frontal crash. So here is what this MDB striker target. So this is the striker target is what is talked on this paragraph. And then mid-door horizontal contour measure. So that is here. So you see this tape is placed there. So that has been taken as a reference. And if you look at that, additionally, what are all measured is vehicle acceleration. So morning you could see the linear acceleration measured in all 3 directions. And now the acceleration is in lateral acceleration of the vehicle occupant compartment is measured. So that's the difference here. And you also have additionally accelerometer 2 locations in the floor, just rearward of A and B pillar, non-stuck side, the other side of the vehicle, right side of the vehicle. And recorded by the data acquisition system. So positive vehicle accelerations are to the right along the lateral axis. So the coordinate system that you have to see. So positive lateral direction is to the right. Right. So if your vehicle is stationed like that, on your right side is going is what is positive direction. So that means it is this coordinate system, right? Is a coordinate system. So then fuel system integrity. So you have to see for that purpose, you have to see the leakage of the solvent after the crash test. First sample to be within a minute, and the second sample is within 5 minutes. During the 5 minutes immediately after the first minute, And then the third sample is to be collected 25 minutes immediately after the second sample is collected. So this all is collected for what to do is the volume of sample is determined, to determine the volume of sample by dividing the weight of the sample by the density of this stored fluid. So you get this. So the entire process is recorded with the video camera equipped with an internal timer, which displays the time of each frame. So this is something that fuel system integrity to test. Then high voltage system integrity. This is in case of the test of electric or hybrid electric vehicle comply with this FMVSS 305. You have to look at this measurement. So what is that is done in this measurement? Is that is monitored to ensure the high voltage electrical system has not been compromised. So post crash observation include the measure of electrode spillage, if any, battery retention, and electrical isolation of high voltage system as per this FMVSS 305. So you can search for this in net and you can get the idea of this standard as well. Additionally, the battery temperature will be monitored to detect rapid increase in temperature that may indicate any thermal runaway condition. Then vehicle crash profile and compartment intrusion. So this is very important in the case of side impact, because you have a crumble zone in the front and the crumble zone in the rear. So they can take more energy, whereas the side impact, there are no crumble zone, rather the pillars strength is what is there. They deform plastically. And there are unavoidable intrusion from this side. So that intrusion should be such that as the side impact happens and the deployment of side airbags that should hold along with the airbag in the front that comes from the front all together and prevent the crash pulse that enter the occupant. But the side impact is worse than the frontal impact as far as the occupant kinematics is concerned in the vehicle. So now continuing with that, let us look at the intrusion profile from the figure which is in the next slide. And the coordinate system definitions are similar to what we have seen. So there will be some particular reference with respect to that. Pre-crash scenario, you will make a measurement of points, and then post-crash with the same reference you would measure the coordinates, and that would help you to get such kind of profiles measured. So pre-crash and post-crash B-pillar vertical profile measures. So this is at that figure. If you look at this figure, so this is taken at this point. So mid-door horizontal contour measure. So that is what is taken as a reference on both sides. And with that height of 60 centimeter also in this, you can see it has got a vertical axis as height from ground and horizontal axis as lateral distance from vertical center line, sorry, vehicle center line. And you see, this is our median vehicle or the center line of the vehicle. That's 0. On this side it's positive, on this side it's negative. So you can see that the door panel and the pillars intrusion inside in the vehicle at that mid-door height. So that is what in that figure 4 that you have seen. And what is happening, that intrusion is not in plane, that goes above the ground, above this 60 mm position. So that's why you have this vertical height from the ground also there. So this red one is the post-crash profile, whereas the blue one is what is the pre-crash profile. So it is just a mirror image of what is on the right in this side drawn, to clearly see what is the intrusion that is along with the B-pillar vertical profile. And again, dummy kinematics and contact locations are very important. And in dummy kinematics, what does that you infer is through the instrumentation of the dummy, you are able to get head, neck, shoulders, spine injuries. This slide gives you what type of sensor the codes are from the suppliers. So these are the instruments that are going in finding the injury level or the crash pulse data. Why do I say crash pulse data? Crash pulse data enters the human, enters the dummy, and that is what is measured at these different parts of the dummy: head, neck, shoulder, spine. So there are three sensors that basically we have seen. One is of accelerometer, another one is movement sensor, that is to measure the displacement, what is the chest movement, and then the load cells. So load cells measure what is the forces. So that is what is shear force here. So AP shear force, what is AP? Please look at it and understand. And LM shear force and axial force, LM moment, so twist moments. So you see this Humanitics. Humanitics is a company that is the pioneer and world-class leader for this dummies manufacturing and the instruments with the dummies. So you have the website of Humanitics and you can see it's wonderful, and you can see what is the olden dummy till today's latest dummies, how they are evolved and useful for vehicle crash testing. That is essential for any automobile manufacturers to get their vehicle certified from the agencies and further striving for the safety aspects in the vehicle, whether it is passive safety aspects or active safety aspects. You have to understand those automakers will are understood that it is mandated that they do hundreds of vehicles of every variant crash tested. So continuing with this dummy responses, apart from those part, you can also see chest and abdominal ribs. What is happening? So for that you have this rib accelerometers. Lateral rib compressions can be measured through this potentiometers. And pelvis, so pelvis lateral acceleration, pelvis octoblum force, what is that? And then lateral ilium crust force. So what we'll see, this all are in injury mechanisms and in detail the physiology, and then these are the different parts of human, what are the injury index, more in detail. So at the moment, let's just to go ahead with these measurements to quantify the injury at pelvis and lower extremities like your left lower femur and so on, right? Through the load cells that can be measured. So these all instruments are regularly calibrated to a known standard. So accelerometers and load cells are calibrated every 12 months. All measurements recorded from these instruments comply with the recommendations of a SAE and Surface Vehicle Information Report. So these standards are enforcing such instruments should be always calibrated as per this norms. And like we have seen in the morning for the frontal offset crash, the dummy clearance measurement for driver, the same is there here. Additionally, what is that you have to understand is for rear passenger, there are clearance measurement definitions. So these definitions, acronyms are there here, and their details, the codes and the detailed locations, and then what is that measurement definition. All you can please read through this slide to have an idea of this clearance measurement definitions. So a huge measurement is going on. To accommodate this all in this one period, I just have to give you the glimpse and the notes like this fashion. So you can spend another hour also to go through this and then read once, you would better understand, right? Yeah. So we also have to look at in detail and ergonomic aspects of crash testing. So these are all comes there. So what is the posture of the seating of the dummies? That should be comfort posture like a human expected to be seated. So this diagrams, these definitions, all something on ergonomical aspects that go into your crash studies. We are going to look at them all also in more detail in our upcoming modules of the course. So with that, I would stop lecturing, and I would like to play two more videos before ending the class, and that would give you the more clarity on this subject, right? On this today's lecture. So let me just go and play two more videos before ending the lecture. So let me just play video of side impact testing. What we have seen now, let's look at a video of that test.
I'm Raul Arbelize, and I'm the Vice President for the IIHS Vehicle Research Center. In our side crash, we have a moving deformable barrier that strikes the tested vehicle at 50 kilometers per hour. That's 31 miles per hour. And the barrier weighs 1,500 kilograms. It's about 3,300 pounds, and it represents a typical ride height and front end geometry of a pickup truck or SUV. These are types of vehicles that in real world T-bone type crashes do a lot of damage to other vehicles when they collide. In the vehicle, we have two dummies, one in the driver position, another in the left rear position. These dummies represent a small female and an adolescent. And in these dummies, we're collecting injury measures from the head, neck, chest, pelvis, and lower extremity regions in hopes of identifying the total injury risks to the occupant in this crash. Besides injury measures, one of the things that we look at is how good a job the side airbags do at protecting the heads from outside intruding objects like the hood of a high-riding vehicle or a tree pole or post. We also look at how good a job the occupant compartment does at holding up. How good a job does it do at resisting that intrusion? And so we measure the safety cage, how much it intrudes before and after the crash. We've come a long way since the Institute's first release of side impact crash test results in 2003. Back then, most vehicles had safety cages that allowed too much intrusion into the compartment, and side airbags were not standard safety features. When you look at what we have today, most vehicles' safety cages are very strong, limit intrusion into the compartment, and the side airbags do a really nice job of protecting the vital organ areas. As a result, we have a vehicle fleet that is much safer and does a much better job of protecting occupants in severe side crashes.
So I hope this video has brought in complete the perspective of the execution of side impact crash test by moving deformable barrier recommended by IIHS. So if you have any doubts, please ask and we'll have a discussion for some time, and then we'll end the class. Do you have any doubts on this videos and the lecture? I hope without any distraction, you are able to go through the videos as well as my lecture part in today's lecture as well. And if you have understood that, I would like to conclude that so far what we have been doing in module 2. So module 2 essentially is for understanding the intricacies of crash testing. So the crash testings has got different types and test configurations. And we were able to get all those different types and test configuration through our crash videos, watching and listening, and through my lecture notes, we were able to look at those technical information as a text form. And we have to now look at what is that important, that is what kind of instrumentation that are there. So we have to go through those instrumentation part, like what is the specification of accelerometers, what type of cameras and their details. So those all are looked at in two specific crash test in our class. One is a moderate offset frontal barrier test. Another one is side impact crash test. Of course, we have also looked at the beginning of this as a full frontal rigid barrier impact test, which is going to simulate two head-on similar vehicles with same speeds. So we have looked at that in first hand with the recommended practice, the Euro NCAP recommendation, and followed that two lectures we looked at specifically for offset frontal crash test and side impact crash test. So tomorrow morning we will meet one more period at 8 o'clock as it is already discussed to complete this module content, and then next week you'll go ahead with simulation models or crash models of our course, right? So with that note, I would like to stop today's lecture, and if there are no question, I would stop recording at this point.